Danny, as always, thanks so much for joining us on the show.
Thank you so much. Nice to be here again.
So, to kick things off, maybe could you briefly describe what this Magic2 is for listeners or viewers?
Sure. The Magic2 EDA tool suite, EDA stands for Electronic Design Automation. These are a package of software patents and IP that we basically develop, particularly for basically creating the next generation of microchips. As you know, the microchips are becoming more complex. The scaling goes lower. We see 7 nanometer, 5, 3, 2 nanometer. They become very advanced process. And that become more complex to actually physically overcome some physics in this area. So designing, verifying, and manufacturing these microchips up to today, we take for granted, we have it on the phone, computer, is becoming more and more hard for engineers. So we provide a technology in the form of IP, and we actually even have one software tool, Epsilon, ready to ease basically the design of these chips, to make what we call to provide more productivity, to enhance the productivity. So this advanced microchip, will not take design over 3 years, but could be done, in 40% less time, even more in some cases. This tool introduces, AI, they introduce mathematical advanced techniques in order to make life of engineer easier, helping basically navigating to design the next generation of integrated circuits.
Now, you mentioned the Epsilon portion of the suite. The company recently announced in the Magic2 press release the patent approval of Epsilon, which is one of Magic2's 8 integrated software applications. Could you briefly explain Epsilon a bit for the audience here?
Sure. Epsilon is targeting what we call the electrical side of the chip. Every chip has basically, has to obey some electrical constraints. If it's the amount of currents running in the wires, if it's how much it's going to heat, things like this. All these factors that basically come from the physics phenomena affect the chip's performance, how fast it can be, what its lifespan, how long it's going to live, et cetera, et cetera. So this, we call it into an area what we call reliability verification, RV. Epsilon is an RV tool that targets to measure what we call in real time during the design phase, the reliability of a chip. So if an engineer, for example, designs a chip, very quick he or she can just let's say, touch a wire on the screen, and the wire, if it doesn't pass, let's say if it's too thin for a current, some things are missing, it will highlight as red, very similar as Microsoft Word highlighting a typo. And they say, okay, this type of wire is, will not meet current constraints. Please make it wider, do some other modification in the design, in the electrical design, to make the design better. This is very crucial, especially with modern chips. They have to, there's chips that are, especially for analog or mixed signal, they may carry heavy currents. We don't want a chip to get overheated, for example, because of excessive current in thin wires. Again, I'm just giving a simplistic example. It has way more phenomena to check. It checks electromigration. It checks IR drop, self-heat. We cover quite a bit of features. I'm not going to go too technical, but the Epsilon is a tool to basically increase the reliability of the microchip, make it live longer lifespan as needed, high performance, and achieving the electrical constraints that we want to do. So not overheat, fast, and efficient. That's by ensuring reliability verification.
Now, as I say, Epsilon is one of 8 tools that make up Magic2. Out of interest, how many of those tools have received patent approval like Epsilon?
Well, we actually have even more than 8. We're actually working as we speak to increase. We cover a wide range of technology in the EDA domain, in the microchip. Currently, we have about 3 or 4 tools that basically received, I believe one was granted, that's the Sigma, that's the electrical connectivity. That's another very, I would say, significant time consuming during the chip design. And again, I'm just going to touch it briefly, not too long. The Sigma patent that was granted basically handles connectivity. When a designer designs a chip, there are electronic components need to be connected in a certain way to function as a circuit. The circuit has to do some functionality. It can support a keyboard. It can work for the monitor, for example, etc., etc. If these components are not connected correctly, the circuit will not function. It's like you connect the wrong wire to the wrong location. Think about a microchip today, have billions of transistors, billions of connectivity to find which connection exactly was not connected correctly, and basically fix it is a huge task. It can take days, weeks, months overall with a team of hundreds of engineers. So the Sigma automatically checks the connectivity, finds the faulty connection, erase it, and reconnect it in the right manner, in the right way. And that's a big, significant productivity enhancement, for EDA, for the microchip area. Engineers, it can take, for example, a chip that typically takes to design a year by a team of, let's say, 100 engineers. You design the same chip, by maybe 8 months, if you use this type of automation, because it saves the time of going to find all the faulty connections and, fix them manually. That's the Sigma. We have a few more others. We have the Phi. I believe it was allowance. We got an allowance notice. It's basically generating automatically a whole blocks of units in a chip. Let's say a chip has many subunits inside. One of them is a USB handler. Then instead of redesign every new chip from scratch, this basically tool reads the electronic schematic and automatically generates the layout. Huge time saving. Instead of going and design it and make the layout over a 4 months period of time, it can do it basically in minutes. So that's another one. We have another one, I believe, in the geometrical rule correction and the epsilon, as we said. So we have a few more coming, few more in the works as we speak.
Now, in the press release for Magic2, GBT's CEO, Mansour Khatib, said the suite could save thousands of hours of engineering time. How much of a game changer is it, would you say, for a firm to adopt and employ Magic2, and how important is that given the ever increasing importance of chips?
Well, given the fact that today the microchips, again, as I mentioned at the beginning, the design and manufacturing become a really complicated task, especially if, when you go to the deep nanometer range. As I mentioned again, 7 nanometer, 5 nanometer, 3, and below, we go in 2 today. So the rules of physics creates lots of constraints that making challenges for the design. If it's on the electrical design side, if it's on the physical design, which the layout physically has way more geometrical rules and electrical rules, and DFM, design for manufacturer rules, and reliability rules, okay, and many others. Okay, I'm just touching a few major ones. So this type of tools, the Magic2, that's going to include, the plan to include many tool suites, each one addressing a different area of the design of a microchip. Fabless companies can basically, reduce their time to market or whole overall project design cycle time, but at least we are very conservative, easily 40%, if not even more. Actually, in some experiments we made, it can do more, but conceptually. But as I mentioned, if, for example, designing a block can take typically 2 weeks, and we have, again, I'm just giving for the example, 100 engineers that's supposed to work over a year, out of these 2 weeks, a few of the verification tasks, we offer automation to be basically done by a click of a button. That reduces these 2 weeks, even, as I said, to 1 week. That's a hard say 50%. You know, if you multiply it over 100 engineers, you can calculate a significant time saving. So yes, we foresee, we know, and we foresee based on our experience that this type of IP, this type of concept, this type of technology can basically push the entire world microchip design, you know, to a high level, to new levels, because more chips could be designed in much less time. And we can see the whole world technology pushes forward, especially when you need today microchips with heavy power, computing power, for example. I don't need to mention for all the AI technology. AI chips are specific chips that are supposed to provide heavy computing power and processing of big data, making them faster, making them better, more reliable, less heat, which contribute, by the way, to a more greener world. We consume less current. It's only going to be good, you know, for the world, for the environment, and for our society. But yes, Mansour Khatib was right about that. There's a significant, we predict here, significant amount of hours, thousands, you know, months, days, years of saving during the microchip design.
Great. Well, Danny, that's all I have for questions this time. But before we part ways, is there anything else you want to add?
No, thank you. I believe we covered the, you know, the topic quite well. The Magic2 is, we actually consider it quite revolutionary. You know, we have many, the major companies in this area, in the EDA domain, there are a few major companies constantly providing, you know, quite advanced automation. But we didn't see it, you know, automation like that where we offer here. This type of automation is not trivial, by the way. If not, then everybody would make it. It's challenging. That's why we introduce heavy AI technology built in with that. We believe without AI algorithms and technology and concept, it would not be possible, especially with such a huge microchip of today. We are so accustomed to the microchip, you know, we every day we turn our phone on and we make a phone call, we turn our computer, everything is great, but we don't even know, we're not aware how much work has been put into the design of these integrated circuits. These integrated circuits are the heart of every phone, of every computer, of every fridge, and every toaster of today, even toys. So, you know, and these microchips, you know, are designed to handle more features. We want them to be faster, we want to be handling more capability, yet be cheaper and do it very quick. So, you know, this is very tough demands, and we believe that our Magic2 tool suite can be a game-changing in this field, because again, especially for many small to medium companies, design houses that want to make chips and today is struggling with, you know, the timing and verification that is expensive. With this, using our type of technology, they could do things much cheaper, much easier, much faster. And of course, the big guys that make the big microprocessors, and they will benefit big time, providing us better technology in shorter times. So we truly believe that our Magic2 tool suite is definitely a game changing in this area.